Imagine a home where your windows anticipate your needs. A home where, as the sun beats down on a scorching summer day, your shades gently lower, keeping the heat at bay and your air conditioning bill in check. As the temperature drops, they rise again, welcoming the rays of the sun. Introducing smart shades, the revolutionary way to enhance your home's energy efficiency while saving money on your electric bill. With smart shades, comfort and cost savings are just a shade away. With an internal temperature sensor, smart shades will change the height of your shades based on the temperature, protecting your home from excessive heat and harmful rays. My name is Veronica Powell, and this is my graduate project for EE 590 Internet of Things, taught by Dale Callahan. The objective of smart shades is to help maintain the desired internal temperature by blocking out excessive heat during hot days and allowing sunlight in during cooler days, ultimately reducing energy consumption. The system also allows users real-time monitoring of humidity and temperature via a dashboard that's viewable in either an internet browser or an iPhone app. Another feature is the ability to control the shades remotely via the same browser or app. This functionality allows users to adjust the shades from anywhere, offering convenience and ensuring that their home environment is always comfortable and energy efficient. Smart shades not only improves the energy efficient and comfort of your home, but also enhances the overall smart home experience. I'm eager to dive deeper into how I was able to achieve these goals and to demonstrate the system's capabilities. Smart shades can be set in automatic mode through the dashboard. When in the automatic setting, the shade will be lowered when the temperature is greater than or equal to 78 degrees. Smart shades can also be turned off, set to raise shade or lower shade, or manually controlling the shade. I'm going to review 3 major challenges that I faced during this project and the solutions to overcome them. Initial testing with a single power supply resulted in some unpredictable results. Using a single power supply for the microcontroller and the motor introduced electrical noise and led to erratic behavior in the microcontroller. When the motor draws high current, it can cause voltage drops that might destabilize the Arduino microcontroller. Ensuring a stable power supply was very critical to avoid unexpected results or malfunctions. To solve this, 2 separate power supplies were used. The motor selection and its integration with a ball chain mechanism was critical for success. I needed a motor with sufficient torque to handle the weight and friction of the shades, especially when lifting them. I had to strike a balance between speed and torque. While a higher speed motor could easily lower the shades, it did not always consistently raise the shade. Conversely, a motor with a higher torque typically had a lower speed. After testing several options, I chose a 12-volt DC gear reduction motor, and it was determined to be the most effective. There were a number of available designs for the pulley available online to 3D print. The design that worked the best was created by Circuit Digest and was available for download from Thingiverse. Careful testing was completed to ensure that the ball chain moved smoothly without slipping or jamming to avoid inefficiencies and failures. After testing various alternatives, a reliable and efficient solution for automating the shades was achieved. Next major challenge was mounting the entire system in a way that was secure and stable to make sure that it functioned reliably. The first step was determining a junction box that would hold the motor and the electronics securely and still maintain an elegant look. I was able to find a junction box from Amazon and drill holes in the top for the ball chain and a hole in the bottom for the power supply. It was important for the design setup to allow for easy access for maintenance and troubleshooting. Being able to quickly reach and service the motor and the pulley system without dismantling the entire system was an important consideration. All components were secured to prevent any accidental detachment or malfunction. And after the initial mounting, several tests were done to observe any signs of instability or issues. Overcoming these challenges for mounting was essential to make sure that the system operates smoothly and reliably. Smart shades can be set to automatic mode with the dashboard through an internet browser, as shown here. When that's in the automatic setting, the shade will lower automatically when the temperature is greater than or equal to 78 degrees. Although the motor lowers slowly, speed was not really a concern. A future enhancement might be a quieter motor though. Smart shades can also be set to off, raise shade, or lower shade for manually controlling the shade. Once it reaches the final position, we'll test those things out as well. Setting to manually raise the shade. Finally, we'll manually lower the shade. We'll mention that the temperature there was 133 degrees, and the reason for that is that I had placed a bowl of warm rice from the microwave underneath the temperature sensor to activate for the shades to automatically lower at the beginning of the demo. Some of the course highlights, this was a great course for understanding the real world applications for the Internet of Things. Throughout the course, we saw how the Internet of Things is transforming everyday life, from smart homes with automated lighting, heating, and security systems to wearable fitness devices that monitor our health in real time. IoT technology is making our lives more convenient. Throughout this project, I gained hands-on experience in designing and implementing IoT systems. I've learned how to effectively integrate microcontrollers, sensors, and actuators. The insights and skills developed in this project have broad implications. This knowledge can be applied to create innovative solutions that address global challenges in a range of industries. This course has provided me with a deep understanding of the Internet of Things and its vast potential. It's been a valuable experience bringing together theory and practice, and I'm excited to leverage what I've learned. Thank you for your time today.